Okay, so hi guys. The title of our honors I2 paper is Detection of Face Masks Using Convolutional Neural Networks. So basically, there have been almost 500 cases of COVID-19 across the world, and face masks are extremely important to help stop the spread of COVID and stop yourself from getting the virus. So basically, the paper that we chose, it focuses on creating a custom object detection model for face masks. Transfer learning was used in this research paper, and the model used was MobileNet V2, which is just version 2. So transfer learning is basically like taking a pre-trained model and changing like the last few layers of the model to suit your particular object detection problem statement. So in this case, they took MobileNet V2 and they changed the last few layers of the model so it could detect masks from images and videos. Now, this is the literature survey. So the data set that was used to train the model, the images were collected from Kaggle and RMFD. The model was trained on 993 images of people with a mask and 1,918 images of people without a mask. So as you can see in this picture, like this is the this is the architecture for MobileNet V2. It was trained on a total of 20 epochs. So basically, the stride is set as 1 for the first block, which is stride is basically like how many pixels your convolutional neural network is shifting over in the image. So if stride is 1, it shifts over every 1 pixel in the image to extract features. And if the stride is 2, it shifts over every 2 pixels in the image and extracts the features. Convolution is basically just like the convolutional layer of your neural network, and ReLU is the activation function. So as you can see in the picture below, like MobileNet V2, like the architecture, it makes use of residual blocks, which is basically like 3 ReLU functions stacked together, and inverted residual blocks, which have convolutional layers with ReLU, the ReLU activation function used depth-wise. Now, CNNs for object detection. So how the entire thing works is that regional proposals are extracted from the image and they are passed to the CNN. So regional proposals are basically like areas in your input image where there is a high probability of drawing a bounding box for that object. And then based on whatever input you give to your CNN, feature vectors are extracted from it. So feature vectors are nothing but like simple matrices. Basically, it's like just the matrix of numbers, and each number represents like a particular feature. So like you could have like a 1D matrix to represent the edges of an object in the image. And then basically once you have the feature vectors, bounding box regression is used to identify the object. And basically bounding box regression just helps you draw like a box around the object so you know what's being detected. Now, the methodology that they've used, so you can look at this flowchart. It's like a complete sequence of the research paper and how they've implemented it. So basically, in short, like what they've done is they've initialized the video or webcam to capture an image. And from that live video stream or live camera feed, they've extracted an image and they've passed it to the model, which is MobileNet version 2. And on the basis of whatever output they get from the model, so if the person is not wearing a mask, it would send an email alert to you that you aren't wearing a mask. And if you are wearing a mask, it shows the object detection with the bounding boxes and the accuracy of the detected object. Now, what they've done to improve the accuracy of the model is they've fine-tuned it. So hyperparameter tuning of the neural network, basically, like learning rate is a hyperparameter that you can change of in your neural network. So basically, a learning rate that is very small, that would mean your model would take a really long time to train. And if the learning rate is very large, you won't get a good accuracy. So based on their experiments over here, they've selected a learning rate of 1 into 10 raised to minus 4, since it gave the best accuracy. And they've added dropouts, which are a regularization method to prevent overfitting. So basically, overfitting is like your model does extremely well on the training set but very badly on the test set. So to prevent that, what they've done is they've used dropouts, which basically help prevent overfitting. So in dropouts, um, a random percentage of the neurons of the neural network are turned off, and basically the remaining neurons are used to make the predictions or draw the bounding boxes. Now Jay will take over with the results.
Yeah, so the results of this research paper. So the first thing we did was to evaluate the model, and a classification report was generated based on the model. Mobile net version 2 achieved 99 precision and 99% recall. And additionally, an accuracy of 97% has been attained by the model, thus proving that it is suitable for deployment as an optimal face mask recognition system. So these are the results of the research paper and of the model. And yeah, finally, to conclude our research paper and to conclude the entire project, so the model that has been made detects the presence of masks in an image and displays a green bounding box around the mask. A custom dataset was used with a total of 2,911 images. Mobile net version 2 was used because of its higher accuracy rates, faster training times, and 30% fewer parameters. And finally, a dropout of 0.25 was used before the fully connected layers, and it was used as a form of regularization to prevent model overfitting. So the future scope of the research paper. So the future scope as listed was expansion of the existing data set to identify face masks worn incorrectly from images and videos. Uh, Another feature is improving the accuracy by hyperparameter tuning and addition of TensorFlow callbacks such as learning rate reduction and early stopping. And we can also use YOLO models like YOLO version 4, YOLO version 4 Tiny, and YOLO version 5 to obtain a higher frame per second rates for video detection. And we can also use the model to detect face masks from images of multiple people. And finally, it's the bibliography of the research paper and the sources and the documentation that has been used to create the model and do the recommended research work. Thank you. And this is our research paper topic.